Hey everyone, welcome back to the channel Code with AKJ. This is day 27 and today we'll be solving LeetCode 933, that is number of recent calls from queue topic. So this is an easy problem but requires a good understanding of data structure for efficient implementation. So we'll go step by step from the brute force approach to the optimal solution. So let's dive in. So the question says you have a recent counter class which counts the number of recent requests within a certain frame. Implement the recent counter class, that is recent counter class initializes the counter with 0 recent requests, and we have int ping of int data type t adds a new request at time t where t represents some time in milliseconds and returns the number of requests that has happened in the past 3000 milliseconds including the new request. Specifically return the number of requests that have happened in the inclusive range, that is from t minus 3000 to t, both are inclusive. So it is guaranteed that every call to ping uses a strictly larger value of t than the previous call. So the problem says we need to design a recent counter class that counts the number of requests received in the last 3000 milliseconds. It supports a method ping of t where t is the timestamp of a new time request, and we need to return the count of requests in the range t minus 3000 till t. The constraint ensures that each call to ping will have a strictly increasing t value. So let's understand this problem statement with the given example 1 here. So we need to count the number of requests in the range t minus 3000 to t. So here I have taken the example 1 with given inputs 1000, 3001 and 3002. So for every request we need to count the number of requests which are inclusive of this given range t minus 3000 to t. So for example, we got our first request, that is 1. So the range becomes minus 299 to 1. The number of requests present in this given range are 1. So we'll return in this case 1. So coming to the next request, that is 100. The range becomes 2900 till 100. The number of requests which falls in this given range are 2. So in this case we'll return 2. Coming to the third request where the request number is 3001, so the range falls from 1 to 3001 and the requests here are 1000 and 3001. So the 3 requests fall under this given range, so in this case we'll return 3. And finally the last number of requests, that is 3002, so the range becomes 2 to 3002 and we have request 100, 3001, 3002. So here since 1 does not fall in this range, we again will return 3 in this case. So in this way, for every number of requests that is coming as an input, we'll calculate the range and we'll check how many of our request falls in this given range and we'll return the number of requests. In this case, the answer would be 1, 2, 3 and 3. So given explanation here, initially in the input they have given recent counter. So use this class to define an object, and then with the help of this object we'll call the function ping with the input time t. So for every request 100 and 3000 and 3002 here, we'll calculate the range and we'll return the number of requests that falls in this given range. So in our case and in our example 1, the answer would be null 1, 2, 3 and 3. So this was about the problem statement. I hope you understood. So let's start with our brute force approach. So the idea here is to store all the requests in a list and we'll iterate over them every time we call ping of t function, and by counting how many are within the range of t minus 3000 till t. So this would be our brute force approach. So let's quickly code this approach and let's do a quick dry run on this given example. So here's the brute force approach code where we'll take a vector of request which will store all the request timestamps, and in our ping function we'll push back all the request time t into our vector and we'll count how many requests are falling in the range of t minus 3000 till t. So every time a request comes in, we'll push that into our vector and we'll count with the help of count variable. We'll iterate over our request vector and we'll check how many falls under 3 minus 3000 till t, and if it falls in this given range we'll increment our count value and finally we'll return our count value. So let's quickly run this code. So let's submit. As you can see, this approach gives a successful submission, but here time complexity of this approach would be O of n for each ping of T call, where n is the number of elements in the request list. So this is because we iterate through the list every time to count the valid request. And space complexity here would be O of n as well, as we are storing all the timestamps here into a vector. The drawback here of this approach would be, as the number of requests increases, this approach becomes inefficient due to repeated scanning of the list. Quickly optimize our approach and not use any kind of external data structure, and try to improve our time complexity and space complexity as well. So in our optimal approach, instead of storing all requests, we can use a queue to only maintain the timestamp within the last 3000 milliseconds. And every time we call a ping function here, we'll remove the timestamps that are older than t minus 3000. So in queue, we'll only store the values which are in the range t minus 3000 to t. So in this way, we'll optimize our storage as well, and not store all the request timestamps which comes through this ping function. So let's understand our optimal approach first, and then we'll move on to the code later. So in our optimal approach, we are going to use queue data structure to store the requests which are falling under the given range itself, and not to store all the given inputs requests. So let's start with our first request, that is 1. So the range becomes -299 till 1. So we'll check the front value of our queue, whether it is moving out of the range or not. So if it falls, we'll pop, otherwise we'll push it. So initially we'll push our request value into our queue, and we'll check whether this moves out of the bound of the given range or not. So if it falls out of the bound, then we'll pop it, otherwise we'll move on to our next request. Since 1 includes in this given range itself, so we'll move on to our next request. So here next request is 100. So we'll push 100 into our queue, that is 1 and 100, and we'll again check the queue's front lies in this given range or not, that is -2900 till 100. So since it includes in this given range, we'll move on to our next call request, that is 3001. We'll push that into our queue, and we'll again check whether the queue's front falls in this given range or not. So since it falls in this given range, we'll move on to our next request, that is 3002. We'll push that into our queue, that is 100, 3001 and 3002, and we'll again check the queue's front lies in this given range or not. So since 1 is out of the bound of this given range, is 2 to 3002, we'll pop this element from the queue, and we'll return the size of our queue. So for every time a request gets processed, we'll return the size of our queue. So in our first iteration, the size of the queue is 1. In our second iteration, the size of our queue is 2. In our third iteration, the size of our queue is 3, and in our last iteration, the size of our queue is 3. In this way, we'll process our request calls, and with the help of queue, we'll only try to store requests which are inside our given range, that is from t minus 3000 till t. So this is how our optimal approach works. So let's try to quickly code this approach, and let's finally submit. So here's the code for our optimal approach, where we have used queue to store all the requests which falls under this given range t minus 3000 till t. So initially we'll push our time t, and we'll check whether the queue dot front lies in this given range or not, that is less than t minus 3000. And if it is less than 3000, we'll try to pop that request value, and finally for every call we'll return our queue dot size value. So let's quickly run this code. So let's submit. So this approach also gives us successful submission, but here the time complexity is O of 1 amortized per ping of t function, that is each element is pushed and popped at most once. So O of 1 in time complexity. So this is significantly better than the brute force approach, where it took O of n time complexity, where we have stored all the request call. Here the space complexity would be O of w, where w is the window size, that is the number of requests in the last 3000 milliseconds. So let's quickly analyze both the time complexity and space complexity of both the approaches we have discussed, the brute force one and the optimal one. So to get a better picture, so in our brute force approach, where we have used a vector to store all the requests coming as an input to a ping function. So in that particular approach, the time complexity was O of n, where n is the number of requests that is coming as an input to the function. And space complexity was also O of n, as we are storing all those requests in a separate vector. And in our optimal approach, where we have used queue data structure to store only those requests which are falling under the given range t minus 3000 till t. So in that case, the time complexity was O of 1, as each element is pushed and popped at most once. So this was pretty much optimal when compared to the brute force approach, which took O of n time complexity. And in case of optimal approach space complexity, the complexity was O of W, where we can say that W is the window size, that is till the range of t minus 3000. So in this way, we have optimized both our time complexity and space complexity as well with the help of queue data structure. So the brute force method works, but it is inefficient for larger inputs. Using a queue improves our performance significantly, making the solution more optimal. So this is a great example of using data structure efficiently to optimize our time complexity and space complexity. So that's it guys. If you found this video helpful, don't forget to like, subscribe and hit the notification bell for more coding content. Comment below if you have any questions or suggestions. I'll see you in the next video. Thank you.